Assalamu alaikum. In this video, we'll be looking at what statistics is and the two main branches it can be divided. Here you can see three definitions of statistics from different dictionaries. The first one says that statistics is the science of using information discovered from collecting, organizing, and studying numbers. According to the second, it is the practice or science of collecting, analyzing numerical data in large quantities, especially for the purpose of inferring proportions in a whole from those in the representative sum. The third one defines it as a branch of mathematics, which deals with the collection, analysis, interpretation, and presentation of masses of numerical data. Now, the wording of these definitions might be different, but you can clearly see that there are four core areas of focus which are common in all of them. The first one is numerical data in large quantities. Second, collection. Third, organizing and analyzing it. And fourth, to make interpretations and inferences out of it. And this is exactly what we will be learning to do in this course. Statistics can be divided into two main branches. The first one is descriptive statistics, which deals with the summary and description of the main features of a dataset in quantitative manner. And for this reason, they're also known as these values that we learn from data as numerical outcomes are also known as summary statistics or simply the summaries. The inferential statistics, as its name indicates, deals with drawing conclusions or making inferences about the population based on a sample of data taken from the population. From our discussion in week 1, you already know that population and sample are two core concepts in statistics. Population is the whole, which includes everything, all the elements, observations, items of interest. And sample is a subset drawn from the population. There can be many samples drawn from the same population, and each of them can have a different composition. You may want to go back to week 1's video to find out what a good sample looks like and how you can draw good samples from population. What are the different strategies to take out a sample from a population? We learn numeric values from the samples, which are known as statistics. And for every statistic, every numerical value that we learn from a sample, there is an associated, a parallel numeric value associated to the population, which is known as parameters. So the numeric quantities that you learned from sample are statistics, and those numerical values which are associated to a population are called as parameters. Inferential statistics or statistical inference is a process of making an estimate, prediction, or decision about the population based on a sample, which is a subset that we draw from the population. So it is depicted in this graphic also. We take a sample out of the population, we learn something from the sample, and then we make generalizations, which is basically that we infer about population's parameters based on these samples statistics. We know that the descriptive statistics is concerned with summarizing and describing the data, and it includes the numerical measures to do so. Let's take a look at an example. This is a data set of the times taken by 25 students of semester 1 to write a simple computer program. And you would expect numbers like these. And you can see that these are 25 different values. Generally, the students of semester 1 are going to be more than this. Usually, there are 50 or more students. And you can well imagine that remembering 50 different values is not an easy task. And also, you cannot, if these values are presented to you, you cannot make any useful information out of it. But if someone tells you that the average of this data is 42 minutes, this is some information that you can use to make decisions. And this is what descriptive statistics will do. It is going to extract fewer values from the large individual values in the data set, and those values will collectively describe the whole data, such as in this case, the average is describing this data set. And now you know that the average amount of time a student of this class is going to take to write a simple computer program is going to be 42 minutes. Descriptive statistics also include graphical tools or for the visual summaries. And we know that pictures are are easier to learn from. So here you can see the bar chart for the same data, and we can, at a very quick glance, we can find out the least amount of time taken by any student is 20 minutes, and the highest amount of time taken is 60. And the values are the values that range between this. You can also find out what are the most frequently occurring values from this description. So descriptive statistics will provide numeric summaries as well as visual summaries. And there are many other tools, many other graphical representations available for different applications. We are going to have a look at them in later videos. The applications of descriptive statistics in real life include many. The basic one is that it provides the concise summary of the main features of a data set, such as we've seen already in the last example slide, that 25 values were actually practically reduced to just one value, which a person has to remember to make any decisions with the help of it. It makes it easier to understand and interpret. We have seen that. Also from these descriptive statistics that we will learn, they form the foundation to understand and apply the inferential statistics. And we are going to see that in due time. Researchers use summary statistics to report their findings in scientific studies. And by doing so, they make the complex data accessible to a larger group of audience. Summary statistics, they're used in quality control processes to monitor and maintain the consistency and quality of products or processes. They're also used to summarize the survey and poll results, providing a clear presentation of the responses and trends. In social sciences, descriptive statistics are used a lot to help analyze demographic data, providing insight into the characteristics of a population, and many other applications. So a quick recap of the descriptive statistics. It involves the collection, analysis, interpretation, and presentation of data to summarize and describe its main features in a quantitative manner. Here we need to focus two main ideas, quantitative and all of these others, and collection, analysis, interpretation, and presentation. And all of this is intended to basically summarize the data. So instead of having to remember many individual different values, we just need to know a few quantities to make decisions. And these include measures of central tendency, which we will be looking at in the next video, measures of dispersion. These are the ones that we will be discussing in one of the coming videos, frequency distribution tables. There are data visualizations and the measures of shape. Coming to the inferential statistics, it involves using sample values, sample data to make inferences or predictions about a population. It helps to generalize findings from a sample, which is a smaller group, a subset, to a larger population, of course, which we cannot exhaustively cover all of that. Inferential statistics question about the data, such as, does a typical semester 1 BSSC student of this university take an average for 42 minutes to write a simple computer programs? We learned that from the data and from the descriptive statistics, that the average of this of that data, of the sample of the data, was this 42 minutes. But now we need to verify whether is it the true mean of the entire population of those students. Is the sample average generalizable to the entire population of semester 1 BSSC students of this university? And once we know that, we will be able to make better decisions and predictions. Such as, see this example, the same example that we've seen in the previous slide. We know that the average time is 42 minutes. Now, the questions written on that you've seen now, these are the ones that inferential statistics is going to ask and answer. And based on that, you can make decisions or predictions about this population, from which the sample that you see here has been taken. Inferential statistics has a lot of applications, such as in medical research to test the effectiveness of a new treatment, in predicting customer behavior based on a sample. Of course, you cannot possibly cover all of the customers, but you can have a sample taken off out of that population and observe their behavior, which later can be generalized. Drawing conclusions about a population's attitude from a sample, assessing the impact of a teaching method on students' performance, predicting stock market trends based on historical data, predicting election outcomes based on a sample of voters, and many other similar applications. So this is a recap of the both of the branches that we have seen statistics can be divided into. We have a population, which is the whole, sampling strategy, which derives a sample or subset from the population. Then we get a smaller portion of this data, which we analyze, from where we'll use the descriptive statistics measures to find some numeric values. And then we use those to apply back to the population from which the sample was taken.